Cool. Yep. So they're started. Thank you. And yeah, so please do take a look at that poll. And if there's a question about, well, I'm not sure what semantic kernel is to begin with, we will answer that question for you today as well. So no fear about that. So yeah, so take a look at that poll and we'll get going. So semantic kernel and Blazor apps, kind of a interesting combination. And I think everyone who has read any news article or anything on the internet in the past year knows all about AI and Open AI and large language models and so on. And it really has become the next big transformational switch, right? You can think of it as, hey, we went from mainframes to PCs and servers, and this is really kind of the next big thing in both underlying technology, but also kind of how we are going to be programming and thinking about applications in the future, right? So really, semantic AI. So the concept of semantic AI is really having this interaction, this prompting, this asking of a large language model to do something for us, right? So if you think about what OpenAI is all about, all the different large language models are all about, is they have been trained on the corpus of information that we call the internet, right? So they have this humongous base of knowledge, and from that, they have been able to gather and gain understanding. And by understanding, I mean think about if you're trying to write a program in Python or C# or Java, JavaScript, whatever, that says, hey, given a paragraph, give me 3 bullets of insight from that paragraph. Like, how would you do that with just straight up programming? It's not something that you could really do. But with these large language models, they have not only the knowledge, but also the understanding to say, hey, what does insights mean, right? And then given context, this paragraph or this page or this book, right? It is able to then not only take that knowledge of what does insight mean, but also take a look at that information and say, okay, here's the information. Now, what insights would I pull out of this? In the same way that you might, upon reading a paragraph or a paper, summarize and provide insights in your own way. The large language models can do that. And in order to program against that, you're like, well, that's not something that I'm used to, right? So it really is, it's an unfamiliar way to think about applications, an unfamiliar way to think about coding, right? And do that today with, just the regular APIs. So looking at Azure Open AI, there are API endpoints for that, which we will see some today, but you need to go beyond that. You need to have this programming model around it that allows you to extend it, right? And that's where semantic kernel comes in. Semantic kernel is one of these tools that will help you increase your velocity with AI, increase your ability to leverage what AI is all about. Okay? So that's all fine and dandy. What are the benefits? Why do I need this? What is what are the common tools I'm going to use? And reason being is you want to avoid that future debt, right? So if you have a whole bunch of just straight up API calls, and there's going to be, well, how do I make sure if this API changes, right? How do I go through and have to update all my API calls for that, right? So when you look at this kind of this to and from, right? So you're using a GPT feature, but like I said, what if something changed underneath the hood, right? The whole idea of semantic kernel is it's integrated, it is aware, it is open source, by the way, in case you weren't aware, and we'll put some links to the open source repository in the chat a little later. But the idea is that semantic kernel is a way to abstract all that underlying knowledge and understanding so you can just go ahead and code and prompt against it. So this concept of prompts, if you haven't done anything with ChatGPT, my first question is, where have you been? It's fun. You got to go play with it. And the second is, like, there's this concept of prompting, which is the prompt is simply the question or what you're looking to get, the answer you're trying to get from the OpenAI large language model, right? And so the idea is we need to take it from, hey, not only just typing in something, but now mixing that with native code. So native code being, hey, large language model, I need you to provide insights from this, the quarterly report from a company, which actually we'll see later in a demo. And so the large language model, like I said, has this base of knowledge, right? You look at Azure Open AI, that was trained back in 2021, 2022. So if you ask it, hey, give me the insights for the latest quarterly report for X, it's not going to know that, right? Because it doesn't have the ability to go beyond what it was trained on. But what you can do is mix that with the native code that says, okay, I can now extract and pull in that quarterly report and then ask the large language model to reason over it. So that's something that Semantic Kernel does very seamlessly, and something that if you're going to do it on your own, now it's like you're bouncing in and out between the language model calls and the native code and back and forth and things like that. Right. So Semantic Kernel also gives you this concept of memory. So as with any REST API call, right, which under the hood, when you go far enough down, that's what all these calls to the large language model are. They're stateless, right? So how do we have memory? How do we have memory and interaction so that the model can have context beyond just the latest interaction? Semantic Kernel builds in that memory for you, right? And then this whole concept of a common approach is we want to enable you, right, to be able to, how do I orchestrate, how do I leverage large language models in a common way so that my team, the next team, the team that comes around in a year has a good understanding of how to do that and they can hit their ground running, right? And then this last bit here, I think is, to me, and we'll see this, is the concept of having these stock prompts, these things that you've optimized, the prompts you've optimized, and now instead of just having them tucked away in your code somewhere, right, which now they're not really reusable, you can build this library of prompts that now can be used across the enterprise. So very, very powerful. All these things are now built into Semantic Kernel. So that's what really Semantic Kernel is, the SDK that allows you to do all these different things, right? So why do you need it, right? It is true, fully multimodal, many models seamlessly. So one of the things here that I want to call out is, so today we're talking about Azure Open AI with the ChatGPT Turbo 3.5 model, right? So that's the model that I'm going to be using in today's demo, right? Well, what about ChatGPT 4? Or what about DaVinci? All these different models that are available to you, and you'd use one or the other for various different reasons. Semantic Kernel doesn't care. Right? You just tell Semantic Kernel, hey, here's the model I want to use, right? And you can swap it out under the hood. Your code doesn't change. Nothing has to change about your code, and you just continue to use those models as well. So when ChatGPT 5 or 6 or 7, whatever it is, comes out, right, Semantic Kernel will take care of any differences that you would have. You'd have to manually do yourself without it. So that's what this is all about. And I know I'm going on about Semantic Kernel. This is a Blazor thing, but I just want to make sure everybody's kind of baseline on what Semantic Kernel is, and we'll go into the Blazor part in the code in a little bit, right? So I also want to kind of point out, as I mentioned, it is Semantic Kernel is open source. There's a community around it. Has a bunch of pre-built skills and connectors already for it, so you can really hit the ground running without having to invent the wheel. Okay, so kind of giving this great marketing spiel of what Semantic Kernel is all about and why you need it and all this. All right, now let's get into some technical bits. What are the pieces that Semantic Kernel has, right? Well, first we have this concept of skills, and you'll hear there's Microsoft, this marketing skills versus plugins. So you hear a lot about plugins, and I'm going to kind of use skills and plugins interchangeably because that's really originally called skills, now they're plugins. So you'll hear me use both. Don't be confused; they're the same thing. So you have a bunch of skills. So skills might be different prompts that you're going to have, that will talk to and request information or request clarity or whatever the case may be from the large language model. And they could also be what we call non-semantic skills, which would be, hey, I need to go get data from a database. Hey, I need to go call an API. I need to go call Bing. I need to go and get information out of ServiceNow, right? Those are all skills in the context of semantic kernel. And the really cool thing about that programming model is you as a developer who's using these skills, right? You don't care if they are skills that go against a large language model or not, right? They're just exposed to you as skills. And more importantly, when we talk about planner, right, is semantic kernel doesn't care either, right? So what is planner? We'll talk about planner in a second. But so then there's this concept of runtime, which is executing the skills in order to get the result you want, and then different memories and connectors, right? So there's already 1,200 connectors in the Power Platform, right? And there's these different memories you can have. So again, the context, which are, hey, I'm going to have my own database, or I'm going to use information from various different sources, all different things that you can leverage as part of semantic kernel. So how does it all go together? Well, one of the key things is this planner concept, which is I have a set of skills. Right? Maybe I have 10, 20, 100 different skills. Some are semantic, meaning they're ultimately going to have a request to a large language model. Some of them are maybe non-semantic skills, which are going to be, hey, I need to go get stuff from a database. I need to go get stuff from an API, right? And the concept of planner is it will take all of those and figure out based on the goal that you have, how can I stitch these skills together to execute in order to get you the end result that you want, right? So you think about that, what's happening is you have an ask, semantic kernel then says, okay, I need to create a plan. So I'm going to understand what skills I have available, what context and memory and connectors that I have, and create that plan. So, hey, first I need to go get information from an API. Then I need to call a large language model to summarize that for me. Then I need to go out and get information from a database and put those two together, right? You can kind of see how they stitch together. And the great thing about it is, could you do that programmatically? Yes, I can call it 1, 2, 3, 4, 100%. And if your solution is fully deterministic, which is always going to be those steps in that order, then that's totally fine. But if you have a solution that says, well, there's going to be some ambiguity here. I don't necessarily know right now exactly every way someone is going to use my platform. I need to have some flexibility. That's where Planner comes into play and says, okay, well, hey, this is a different request than I normally have. I can stitch it together instead of 1, 2, 3, 4. I can do it, 1, 2, 7, 9, and get the results you're looking for based on the skills. And then semantic kernel can take that planner that was put together and run those out and get the results back for you. So where does semantic kernel fit in? So this is a very kind of high level architecture, right? Hey, got my UX, got my app runtime, got my knowledge or state for these contexts and memories, and got my AI platform at the bottom. And over here, I got this evaluation, right? And this is where the Azure Open AI specifically it really has a lot of value is around the security, safety, and responsible AI, right? So we have these layers built onto Azure Open AI that not only, number one, keep your information yours, right? It's your security, it's your knowledge. It's not shared or used to train anything else, right? But we also have these things on top, like on a responsible AI perspective, like, hey, we're not going to allow hate speech. We're not going to allow, some things that you can define. These are not things we want to have, and we can make sure that's filtered out at that level. So when you it's like, okay, now this other next level here, I got all these different pieces. I got to talk about planning and discovery, and I have all my different plugins or skills. Right, and I have my language app framework. It's like, okay, this is now we've gone that next level down. Where does semantic kernel really fit? It's really right in here, right? So we talked about the planning, the orchestration, the plugins. We got the memory, which is the persistence, the language-specific framework. So semantic kernel is C#, Python, and Java today, right? So all available in all three different things, and how it interacts then with your UI components, which is a concept today with Blazor, right? Then also, it can call out and use other APIs, and then ultimately leverage, right, the foundational models that we're going to be looking at. Okay. All right. So that is what Semantic Kernel is all about. That's what it's kind of there for. Looking to see, I don't see any questions in the chat. So I will next kind of flip over then over to some code, kind of show you where we find Semantic Kernel with a Blazor app, right? So right here I have I got a Blazor app, which I believe I have running. Yes, I do. Okay. All right, so this is a Blazor app called Executive Summary Meeting Prep. And what it's doing is the concept of this app is I put in the name of a company, and into my Blazor app, I use Semantic Kernel then to go figure out, hey, who are the executives for this company, right? Along with some other connectors. It says, hey, I need to get the current executives for this company, which means I need to go out to the internet to get it. Because remember, the large language models are trained in 2021, 2022. Those executives could have changed between now and then. And then what's going to do is I'm going to go ahead and pick an executive or two. Let's go pick. Let's see, this is Microsoft CEO and CFO, and I'm going to say, okay, I'm going to go ahead and put in a meeting topic. I'm going to generate some prep notes. Boom. Okay. So what is it doing? Let me go back over here. So we have our Blazor app. So you will notice if you took part in the first session that Vincent did, his Blazor skills are totally rocking, right? He his whole Fluent component library. Mine are a little less skillful, so more of like I'm on that 101 kind of level, right? But you can kind of see here I have I got some different sections. I'm using some variables for hints, and got some divs going in here, and which make up the different pieces. So I really have this, all of my app is in this index.razor as I hide and show different things for state. Okay, so let me make this a little bigger for you as well so you can see everything. There we go. Okay. Now I go down into the code sections. This is the part that I love. I love Blazor. First time I did Blazor, I needed to do something that was more dynamic, and I'm like, oh, I don't know JavaScript well enough. I don't know all the the Angulars and the all the different frameworks well enough. Then I realized, oh, wait a minute, there's this Blazor. Blazor's cool, right? It kind of abstracts that for you. And then I first did it in action. I'm like, where has this been all of my life? All right. I can just write some HTML, some C# code, and Blazor takes care of all the dynamic and all the interaction for me. It really hit it for me when I was working with a table, and I said, oh, I need to dynamically add another row to the table. And when I dynamically added another item to my list collection, it automatically added that table. I'm like, all right, I'm done. This is beautiful. I'm sold. So that's my discovery, my aha moment for Blazor. If anyone hasn't had that aha moment yet, but that's what that's all about. So let's kind of walk through. So that first button, when I typed in that Microsoft, gave me that list of Microsoft executives, right? First thing I'm doing is I'm go ahead and I'm making a call to my OpenAI to get my list of executives, right here, and then setting that here, which is then bound to that table of executives, right? And then what I did is I have if I build that up here, there's a checkbox against each one. You saw that. Then when I pick the executives of interest, I went ahead and then called the next one, right, which is get company and executive info. Pretty straightforward. And again, just go ahead and making those calls. And because these are bound, everything gets updated. I'm doing a couple different things now too. I'm getting executive bios and priorities, and we'll go to the semantic kernel bit of this in a second. Then I'm getting their quarterly statement summary, right? Then I'm getting their news articles for on that meeting topic. So remember the meeting topic I had was Azure Open AI. Okay. So let's see what it did here. So now I remember I picked Amy Hood and Satya Nadella, our CFO. So here's a quick bio about Amy Hood, right? Here are business priorities, right? So these are things that I just asked Semantic Kernel. I just asked large language model, hey, go get me this information. And I have some references. It's always important, as with anything. This is one of the things you look at. You hear about the Microsoft and our concept of AI is this concept of Copilot. So you hear Copilot everything Microsoft these days, right? Why do we call it Copilot? Well, because while the large language models are really, really good, right? They're not a replacement. They're a yes and. Yes, it can do this, but let's double check it, right? What are the sources that you use this to get this information from, right? And so you can go look, it's always a good idea whenever using a large language model is to validate. Yeah, did it do what I wanted it to do? I was kind of blindly accepting what it did, right? So that's why I included references here. All the different business priorities here, right? Oh, look at gradual growth from AI services will pay off mainly in the second half of fiscal 2024. Yep, I can guarantee that's right because that's something that she told us at our fiscal year end meeting in July, right? So these are all recent information. We'll talk about how did it get that recent? How does it know this, right? This, remember, large language models were trained in 2021, 22. This is recent information. We'll talk about that in a second. We got Satya Nadella stuff in here. So then we have some quarterly reports. Stuff again, it's, FY23 Q4. So our FY23 ended in June so this was our last quarterly report that we had here. And then we got article insights. So we got some articles here that are all fairly new. And again, what did it do? In this case, it pulled out from the internet an article and then summarized it. So let's look at how that worked, not only in Blazor, right? Which again was just, it's freakishly simple. Go get, run this quarterly statement summary, which is bound up here. I should just go ahead and locate it. Here, find all references. Boom. Which went up in my other window over here, so you can kind of see. There it is. All right. There it is, just in this div. So you can think about the beauty of Blazor, I populate that and boom, it just shows up on the web page, right? Think about what you'd have to do if you were doing this, with JavaScript, right? And the back and forth, and you have to orchestrate all that communication, orchestrate all that. Blazor just does it, right? There's value for that. It's going to put it in. Now there's links and titles. That's me. That's an extension that I had. Just kind of in case you're curious, right? What it's doing is I have titles so that it'll format it properly with headers, and then the links bit, right, is all about, hey, I'm going to just do a regular expression and find all the links so that when it comes up on the page, they're actually hyperlinks, right? So that's nothing to do. That's just good old plain programming. But yeah, when Blazor says, hey, here's a summary, boom, there it goes, and then it's in. And again, it's just, I've been programming a long time, doing a lot of web stuff for a long time. And when, like I said, when this came about, I'm like, all right, this is it. I found my home, and this is awesome stuff. So those are the different calls that it's making. Now let's talk about how we've integrated that and use the large language model for that. So I have this this class, Azure Open AI, does a couple of things, right? I got the semantic kernel in here. I got some skills, which we'll talk about, right? So I got this init skills bit here. So this is really this first thing. Remember I told about, hey, you're kind of abstracting the model you're using from semantic kernel itself. Well, I just have the model that I'm using as part of a configuration. Hey, what's the URL for it? What's the key for it? What's the model name that I'm using for it, right? And I'm just, hey, just building it right here. Boom, that's it. That's the connection, if you will, to the model, which means I can swap out the model underneath, and everything just continues to work. Right? So if you were trying to do that with straight API calls, well, now you're going into your code and you're changing your endpoints. If there's nuances of making a call to the different models you're looking at, you have to understand that you have to implement those. So Semantic Kernel will handle that for you automatically. Again, just great. Okay. Now I'm going to start implementing skills. Okay. So let's first take a look at what a semantic skill is. So this is a call out to the large language model. So I'm going to go and actually going to do this company skill one here. Boom. So Semantic Kernel has this great way of creating this library. I remember before, like, hey, this is the awesome part of Semantic Kernel, this library of skills. And the way it does it is you just have a hierarchy of folders, right? In this case, my base folder is skills, right? And then I can import my skills from directories, starting with my root one to say, hey, I want to pull in all the skills that are in the summarized skill folder. And then I want to pull in all the skills that are from the company skills folder. It's going to go through and say, oh, I have 6 skills here in the company skill, and I have 5 here in the summarized skill. I'm going to make these skills available. Right now I can use them, and we'll take a look at what that looks like. So let's go executive list, right? I have 2 pieces to it. To each skill, there's a config JSON and a prompt text. Okay, so the config JSON, the most important piece to it is this description. What does this skill do? And why is that description important? Because when we talked about planner, where you don't know exactly what order things are going to run. In order for the planner to figure out how to take your collection of skills and put them together, right? It needs to know what those skills can do. And it does that through this description. Okay. There's some other pieces. So these all the max tokens, temperature, frequency penalty, those are all kind of under the hood knobs and dials you can spin for the large language model. The 2 most important ones here are the max tokens. So any call out to a large language model is billed by tokens, right? And so you can say, hey, I know I don't want a very large response from this, so I can tone tokens down. So for instance, like ChatGPT 4 has this concept of you can have 32,000 tokens, right? And what I'm saying, hey, you know what? No, I know this is not going to be that big. I'm going to tune it down to say a max of 1,000 tokens. And the second one is temperature, right? So it's how precise do you want me to be? How consistent do you want me to be in the answer, right? So, 1 is, or 0 is, I want you to be as consistent as possible. So if I ask you the same question multiple times, I'm going to get a very, very similar answer, if not the exact same answer, right? And then you can tune that up to code in some variability. So those are really the key big pieces in the config JSON. But the real good stuff here is in this text prompt. So prompt engineering, right, is going to be the big thing up is how do you properly ask the large language model to give you information, right? So someone had described to me once as large language models have all the knowledge of the internet in the mind of a 2-year-old. So if you've ever interacted with a toddler and you're trying to give them instructions, you need to be very precise into exactly what you want them to do, because we may have built into what our understanding of asking the question. If you ask an adult, they answer that that question, they will have some context. They have a history with you to understand what you're asking for in the way you ask it. Large language models don't have that context of you and how you're going to ask it. So you need to be very specific in what you're looking for, right? So you can kind of see here what I'm asking for in this executive list is, based on the information I've given you, provide a list of executives, including their name, title, and company name. Okay. And then here's an interesting one. Do not provide additional information or make assumptions beyond what I've provided. Right. So this is basically saying just the facts. Just tell me what you know. So if you've ever heard of, in the large language model world, this concept of hallucination, right? What does that even mean? It means that large language models have a tendency to make stuff up. And why is that? Like, why wouldn't they just give you the information or tell you, I don't know? if you look back and under the the history of how they were created, and how they're trained, they are trained to always give you an answer, right? That's their goal, and their goal of existence is giving you an answer. And so if they don't know and they're not prompted to not make something up, they're going to give you an answer, and it might just be wrong, right? I asked ChatGPT at one point in time, who is Michael McKechnie? Who am I, right? Well, not being a public figure, it didn't know, so it made something up. Now, what it made up was pretty cool, right? It says I'm a movie star, right? I've starred in a couple of really large movies. I have an Oscar nomination, and also I've done TV and have an Emmy nomination. None of that is true. That was totally made up, right? So what you often want to make sure you do is, hey, don't give me any of that made up
Could
stuff.
have been true though.
Just give me. What was that?
It could have been true though.
I guess it could have been true. Maybe it's predicting the future. Maybe
Right.
I have a future in the movies. I don't know, but not quite yet. And there's the next cool thing here is like, hey, how do I want the response? Those not only can you tell it, hey, here's what I'm giving you, here's what I want you to do with it, but here's how I want it back, right? And the language model is very good at understanding that, right? And so I've asked for it in well-formatted JSON. Now, why? Because I'm programmatically using that later. So if you can give it to me in a format that I can easily use in code, all the better, right? I don't have to dissect some paragraph that you've given back to me, right? And so you can kind of see there's all these really great pieces of this. And I mean, like same thing for the quarterly report. Summarize the quarterly report in 1 or 2 paragraphs, and extract key insights, right? So remember I talked about it's trained on all this information, and from that it has this idea, it has this understanding of what an insight is, right? What does summarize mean, right? It understands how to do that, and also, that's right, include a list of references, right? So I'm asking us, hey, just don't just give it to me, but also tell me where you got it, right? And then I'm saying, hey, give it back to me in this particular format, because what I'm going to do is I'm just going to throw this back up in the code, right? So that's the concept of a semantic skill. It says, hey, here's the prompt that I'm asking. I'm gonna have, there's gonna be some input to it, right? And this is what I want you to do. Now, there's also this concept of a non-semantic skill, which actually this one actually doesn't have. I take that back, it does. Which can go ahead and, so here's all the different methods. So you'll see I'm doing a lot of async calls, doing some tasks, and why am I doing that, right? Well, here, getting Bing results. This is a non-semantic skill, right? So this is I need to go and go get stuff from Bing, right? So I'm going to go ahead and make a call out to Bing to do that. And so why am I doing a lot of async calls and multi-threading and tasking? If we've ever done a call to a large language model, it can take a while to come back, right? They can take a second, 2 seconds, 3 seconds, depending on the model, depending on the ask, right? So because in my demo app, which is pulling out a lot of information, I'm getting information on 2 different people. I'm getting summaries and bullet points and priorities on all those people. I'm going out, extracting a quarterly report, doing all this, getting article insights, doing all this from all this stuff. That's a lot of calls to the large language model. So I can say, you know what, to make it faster, I'm going to thread them out and go that route. So that's why I did it that way. Okay. Now, one thing you see I'm not using here is Planner. I didn't use Planner because this app is very deterministic, right? I'm going to do this, I'm going to do that, I'm going to do this, right? So there's no variability in there. So there's really no value for me in using Planner. But here's a different app that's going out and using a couple other different skills. So again, you can see I'm leveraging some skills here. Here we got some semantic skills, so I got a non-semantic skill. No, sorry, semantic skill for Fabric skills. So if you ever used Azure Fabric, a new data model, right, where you can pull in information from multiple different data sources and expose as SQL. So I have a data connector here. Oops, sorry. I'll look at the Fabric connector first. I have a Fabric skill. which takes a text question and will produce a SQL query for me. Based, again, very simply, I'm saying, hey, what are you supposed to do? You're supposed to create a SQL statement. There's some qualifications on what I want you to do or not do. And then here's the definition of the tables that you're looking for, right? So that's the prompt that I'm going to be putting in. What's the description? Turn a large natural language question into a select statement, right? So that's what I'm asking you to do. So that's a semantic skill. I'm going out and asking the large language model to do something for me. Then I have this what they call a non-semantic skill, which is actually getting data from the database. You can see here I'm registering it with an attribute, got a description there going out. And the way I'm leveraging that here is you can see I have this skill get function fabric skill that goes out to the large language model. I have this data connector skill, which doesn't, but I'm calling them in exactly the same way. And then I have here another one called insights that goes out to large language model. And this one, adaptive card, is actual straight code. But you can kind of see I'm just calling them as skills. Now again, you're also saying, hey, you're still not using plan. This is true. But so what I've done here is stitch them all together. But I do have this concept of planner, which you can kind of see from a code perspective, way simpler. It says, okay, what's your goal? And then I have a prompt from the user. Right, but then I also have a goal that I'm going to send to the planner. So based on the user input, provide the SQL query and get the information from the database, right? And then I have one call, create plan. So what Semantic Kernel is doing here is saying, okay, what are the skills I have available? What's the goal I have? And the prompt that I'm getting from the user. How do I stitch those skills together to get the solution? Right. And so really the only pieces you really need here are create a plan and invoke the plan. Right. These are just logging pieces. And what it ends up doing is basically this. Right. So every time I run it, it does the same sets because in this particular demo, it's pretty deterministic. But what I want to show here is, while yes, you can do things deterministically, call, right? You can also simplify, especially if you don't necessarily know, in fact, in front piece of how it's going to go, you can just, hey, go and create a plan and invoke it. So it's really, really powerful in the way that that works and the way that it runs. It's really, really cool. I also want to call out here. Remember I said how you can register these things as skills, and you don't have to know as a developer whether it's a semantic skill or non-semantic skill. Is it going against the large language model or is it not? Right. You know, I actually got a little confused. I'm like, oh wait, this is a non-semantic one. So this adaptive card is an interesting one. So I know this is a Blazor talk, but this particular solution was looking to create an adaptive card for a Teams endpoint. And I had actually adaptive card semantic skill, which says, hey, given the input, create a adaptive card for me. And oh, by the way, here's the format. Right. So that was one skill that I had. And then I'm like, you know what? Why do I need to go do that? There's a very simple SDK to create it. So I have some regular, good old straight up C# code to do it. And I'm going to create a semantic skill, register it, if you will, as a semantic skill. So what I was able to do is when I first wrote this piece is this was a call to the skill that went out to the large language model. And I'm like, well, you know what? It was a little slow for me. And there's really was not really any point in doing it because an adaptive card is deterministic, right? It's going to be the same all the time. So it's really easy to do in code. It's going to be faster and cheaper. So I instead then registered the other one and said, I'm going to use that skill. Right? This code stayed exactly the same, except for the fact that I changed the function name to be the deterministic one versus the large language model one. So again, as you're looking at looking to leverage semantic kernel in your apps, right? Is you always have to make that decision. Is this particular step in the process best served by a large language model? Or is it deterministic enough that I can just go ahead and write it as code? Or and the third piece is I need to go get information from an external source. In which case, yeah, it's going to have to be a non-semantic skill. It's going to be a connector out to Bing, or it's going to be a connector to a database, or it's going to be a connector out to ServiceNow or Salesforce, whatever the case may be, for the different API pieces. Right? So all of that, then, when you look to kind of wrap this all back up into the pretty picture of Blazor and Semantic Kernel, is when you look at the Blazor piece, right, from the code perspective down here, it's just making this different plain old, what looks like regular old C# calls in my case, right, and making calls to a class and its methods, right, and it's injecting those and putting them into my HTML all dynamically, all automatically for me, right, which again is like the awesomeness of Blazor. I can't state how frustrated I have been over the years with JavaScript and all that, and all the different things that have come out, and then realize, hey, look, I don't have to write a single line of JavaScript at all, but still have that dynamic feel. Well, not dynamic feel, but truly dynamic application. Whether it be, if you were from what Vince was talking about, whether it be a WebAssembly, right, or Blazor server. In my case, it's Blazor server. It's going back and forth. So I'm making database calls, and just easier and more secure for me to do that as Blazor versus WebAssembly. But either way, to the user, it makes no difference. But because I still have that dynamic feel, I can still go and call out to those classes and all that dynamically like this, right? So I'm just making these calls out. The pieces and parts are just straight up calls. I just happen to be now calling out to my skills, right? Using Semantic Kernel to go and do that for me, to generate that insight, to generate those summaries, to generate the pieces. Extract information from text, right? Because when you think about that first piece is, hey, I need to get the name, first name, last name, and company name and title of these people. Well, where am I getting that from? I'm getting it from a web page from the internet. But Semantic Kernel and a large language model can say, oh, this is a person's name and this is their title. I'm going to return that back to you, right? Again, something that if you were to try to parse that on your own, what a pain, with the unlimited number of formats people might have in a website, but the large language models can do that. So infusing your application where appropriate with these different capabilities of a language model to really, really accelerate your development and accelerate your ability to provide value is, I can't understate it enough. I'm pretty sure that this application, which does all this information, the use case is pretty straightforward, right? Hey, I need to get information about people. I need to go get their bios and business priorities and all that kind of stuff. To do this manually, God forbid, try to do it programmatically. You're talking probably, a couple hours at least, right? Just to read a quarterly report, much less summarize it and gain insights on it, right? You're talking at least a couple hours. And then, the same thing for each of these different pieces. So this report, right, might take a person or a team, 10, 15 man hours or person hours, if you will, to do this, right? And what we're able to do, leveraging, using your Blazor app to get a nice visualization for it, a nice dynamic interface for it, right? Using Semantic Kernel to integrate and talk to not only the large language model to be able to generate these insights, but also the different connectors and non-semantic functions to go out and get information from the internet, right? To go out and extract and find the quarterly report for the company, right? And then feed that in, right? These are all things that the large language models can't get that information. So these non-semantic skills can integrate all those together. Now you have the ability to produce, like I said, this report here, which to try to do it manually or even programmatically would be, tens or 20s of person hours to do this. And I can get this page to load in, 15, 20 seconds, right? So think about that as you're looking to say, there's a lot of hype today, right, around AI and what it can do for you. And yeah, it's on that steep vertical hype curve right now of, hey, AI can do everything. Well, I'll say this: there's a place for AI in a lot of things, right? And the skill and the value that you can provide is understanding where that value is, right? And then being able to leverage it. And that's where semantic kernel comes into play. Is it's a very effective, open source, reliable way to use that information from the large language model to then integrate it with your apps, right? And from a skill perspective, like creating these prompts, there's in the same way today, you're writing code, you write some code, you test it, you tweak it, you get that algorithm just right. You're gonna do the same thing with, with these prompts, right? There's gonna do the same thing. It's like, oh, I need to tweak a little bit. I'm gonna run it, test it, and tweak it a little bit. And that's, again, the value of semantic kernel is now I have this proven set of prompts, this proven set of skills that I can reuse and share across my company. And now they're going to be the same all the way around. They're fully tested, fully proven of what they can do. So people don't have to keep re-engineering it, right? So you can kind of think of these skill folders, right, as reusable components in the same way you'd share, share microservices or share libraries today in your code. These skill libraries can be the exact same thing for the large language model piece, right? You fully debugged it, you fully tested it, it's consistently giving you the information. Now you have this shareable component you can plug in very simply into semantic kernel across multiple applications and provide value and get value from that. Okay, I have finished my talk. I hope that my exuberance and joy of Blazor has worn off on you a little bit. Because again, it's just freaking awesome. And then the ability to integrate that with and leverage large language models through semantic kernel, really in this example right here, has just made this application just truly even possible, right? Great simple UI. And oh, by the way, how long did it take me to put this application together? My first pass for this app, which didn't have all the threading and all that in it, literally took me 3 hours, right? Which I thought was pretty cool. And I went from somebody in the morning of one day saying, "Hey, is there anything we can put together for this meeting tomorrow morning?" I'm like, "Well, I can certainly try." And then with the combination of Blazor and its ability to really easily create a interactive, beautiful UI with semantic kernel and the ability to easily integrate and extract and use large language models. First pass of this took me, again, about 3 hours to do. I demoed it the next day. They were blown away by it, right? And what you can do. And it took me less time to code the entire application than it would have to even put one report together, right? So again, so there we go. All right. I'm done talking. I don't know if we have any questions out there. Feel free to type in anything you want in the chat window, and we'll go from there. Oh, Vincent, do we have? No, I don't see anything in the chat.
No. It's
all right.
I think it was all clear then.
Okay. Very good.
Oh, there's somebody typing
so
right
it's
now.
kind of all right.
Is the sample app available on GitHub?
It is not. It is in GitHub. It's not public right now. I need to scrub it first. I do. That's questions come up multiple times. Tell you what I'm going to do. I'm going to put the URL for it in the chat. If you try to get there right now, it's going to say either GitHub usually says it doesn't exist. But if you look at it maybe tomorrow, once I scrub this guy, then it'll work. How about that? Summary. Oh, I don't want actions, but all right. So I'm going to put this in the chat. Like I said, right now it's not going to work because it's a private repository. But once I do make it public, hopefully later today, I'll make that my mission by the end of business today to to scrub it and make sure it's good to go. Then it will be available.
Probably people will need to use their own Azure Open AI settings.
Yes. Yeah. So okay, nothing private here. Okay, good. Yeah. So there will be in the app settings JSON, there's an Azure Open AI piece here. Right. So you'll put in your own label deployment endpoint in the API key, and then it'll just work. Any other questions? Well, you're very welcome. All right. Well, hearing none, I think we can.
Well, we'll give you some minutes back then. We hope to see every one of you and a few of your colleagues again next week when we have the third and final episode of this Blazor series, where we'll take a closer look at other OpenAI, Azure OpenAI integrations that we can have with Blazor, like, for example, the one that I posted here in the chat where we're using ChatGPT. As an interface, and well, you can imagine combining this with the stuff that Michael did. That would give you a pretty powerful application. But that's not what we're going to do next week. It's just going to be more individual examples. All right. Thanks, and hopefully see you next week.